Imagine a grand symphony, conducted by an endless array of stars, planets, and moons, each contributing to the performance. However, in perfect harmony, there is a specific section of this cosmic orchestra that has ensnared the attention of astronomers for an extended period: the exoplanets. These are planets that exist outside of our solar system, hidden somewhere in or near the vastness of the Milky Way. You may be astounded to learn that, amid the countless celestial bodies, there are exoplanets strikingly similar to Earth, so remarkably similar that they could be the cosmic counterpart of our planet. Allow us to enter Proxima B, an intriguing realm located just 4.2 light-years away. The James Webb Space Telescope plays a crucial role in our quest to unravel these cosmic mysteries. Now, imagine your thoughts traversing the enormous Milky Way galaxy, home to over a quadrillion exoplanets, a number that includes 15 zeros. To put that into perspective, if the size of these exoplanets was comparable to grains of sand, they wouldn't just fill the Grand Canyon, they would go far beyond it. In fact, it would be like creating a second monumental geological feature, Grand Canyon 2.0, sprawling across unimaginable scales. Surprisingly, approximately 20% of these enormous objects have been referred to as Earth-like in terms of their geography and climate conditions. This means there's a 1 in 5 chance of finding a twin of our planet. And that's not all. Surrounding these planets could be another quadrillion moons, rocky satellites locked in a gravitational dance with their parent planets. Taking into account the possibility of locating a different celestial body that could host life, or might one day do so, the universe is abundant with potential. Now that we've laid out this amazing cosmic scale, let's introduce the ultimate instrument for locating its intricacies, the James Webb Space Telescope. This cosmic detective, equipped with its enlarged main mirror composed of flexible segments, surpasses even the most cutting-edge optical instruments available today. This is no ordinary lens. It's 6.5 meters in diameter, nearly 2.7 times larger than the Hubble Space Telescopes. Imagine the tiniest of details this mirror can capture, even from the faintest twinkle billions of light-years away, and then analyze the planets around it. What makes the James Webb Space Telescope truly revolutionary is not just its seeing power, but also its advanced technology, including sophisticated sensors and spectrographs. These instruments can do far more than just observe. They can examine and process the light emitted or reflected by these vast celestial bodies, allowing researchers to decipher their atmospheric composition, chemical balance, density, and even mass. Acting as an astronomer in space, the telescope can check to see if a planet contains organic compounds, water, or even oxygen. The James Webb Space Telescope has the extraordinary capacity to answer these questions, elevating it from a simple observer to a genius in science. It's not just an upgrade over Hubble, it represents a leap forward in our comprehension of the universe. If Hubble's discoveries amazed you, prepare for a truly extraordinary era of revelations. As we broaden our understanding of the universe, we must focus on one particular star in this celestial narrative, Proxima B. Since its discovery in 2016, this enigmatic planet has enthralled astronomers and biologists alike. It's been compared to a Shakespearean drama, filled with complexity and intrigue. So what's the allure of Proxima B? First, it's incredibly close to our galaxy, located just 4.2 light-years away from Earth. To put this in context, if we could travel at the speed of light, it would take just over 4 years to reach it. Roughly the same amount of time it takes for a TV series to become a cultural phenomenon. Now consider the significance of this proximity in the grand scheme of the universe, which spans more than 93 billion light-years end-to-end. Discovering a planet so near, and so Earth-like, ripe for scientific investigation, is like finding a diamond in a mountain-sized pile of rocks, a precious gem that could hold profound secrets about existence. Proxima B has the potential to change everything we know about habitability and life beyond Earth. Not only is its proximity to Earth significant, but equally intriguing are the hints that it may not just resemble Earth, it could be Earth 2.0. Proxima B resides in harmony with what scientists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Picture winding streams and cascading waterfalls, expansive lakes, and perhaps even oceans as deep and mysterious as the Mariana Trench. However, before we allow ourselves to fantasize about visiting Proxima B, we must consider a few characteristics that set this distant world apart. A single day on Proxima B lasts just 11 Earth days. Imagine a dawn that not only marks the beginning of a new day but unfolds gradually, with leisurely sunsets and afternoons that last for ages, generating golden opportunities photographers dream about. While this may sound idyllic, it has significant repercussions for climate and for Proxima B's potential to support life. How would human biological rhythms adjust? We would require both light and dark cycles. Would we need to eat multiple times a day to accommodate the length of its days? Would our sleeping habits alter? The patterns of life on Proxima B could be both strikingly similar to and remarkably different from those on Earth. It's a cosmic puzzle, an enigma wrapped in a mystery, challenging our comprehension of what constitutes a planet suitable for life. How can we then assemble accurate and reliable information about a planet we have yet to visit? This is where the James Webb Space Telescope comes into action, like a massive Swiss Army knife, a sharper instrument for scientific investigation. It does more than function as a telescope, it is a powerful research facility floating in the void of space. With its innovative instruments, astronomers can study planets through an array of scientific tools so advanced, they make even the most sophisticated earthly laboratories look straightforward. Using advanced spectrographs, the Webb telescope can analyze the light emitted or reflected by these far-off planets. Each and every element or molecule in a planet's atmosphere interacts with light at distinct wavelengths. By concentrating on these patterns, researchers can perform a celestial biopsy, revealing crucial information about atmospheric pressure, chemical composition, and the potential presence of life-sustaining compounds such as water, carbon-based molecules, and even oxygen. Space science is more than just studying distant stars. It's more akin to space forensics. Researchers do not wait idly for clues, they actively search for them, examining the molecules and atoms that make up these faraway worlds. The James Webb Space Telescope is not just a passive observer. It is an outstanding research facility, a specialist and a vast analyzer all rolled into one. With every observation it makes, the James Webb Space Telescope pushes the boundaries of what we know. It's not just capturing images, it's telling stories written in light, in the language of physics and chemistry, across the expanse of space and time. And as we decode those stories, we begin to grasp something astonishing. We're not just looking outward, we're looking back. The telescope's powerful instruments allow us to peer billions of years into the past, to witness galaxies forming shortly after the Big Bang, to observe the birth of stars, and perhaps even catch glimpses of how planetary systems, like our own, came into existence. What once was the stuff of dreams, distant worlds with the potential for life, habitable zones around unfamiliar stars, alien atmospheres with oxygen or water vapor, is now within reach, not by touch, but through sight, analysis, and imagination. Yet, amid this technological marvel, a simple truth remains: we are explorers at heart. From ancient navigators charting the stars with naked eyes, to modern scientists building colossal mirrors in the vacuum of space, the desire to understand what lies beyond has never left us. The search for another Earth isn't just about finding a place to go, it's about answering the oldest questions of all: are we alone? Is life a cosmic rarity, or a common thread woven through the universe? Proxima B might be one of many answers. Or it could be the key. Its orbit around a red dwarf star, its location within the habitable zone, and its size, close to Earth's, all make it a prime candidate. But it also faces challenges. Red dwarf stars are known for intense solar flares, potentially stripping a planet of its atmosphere. If Proxima B lacks a magnetic field or a thick atmosphere to shield it, conditions might be far less favorable than hoped. Still, we've only begun to uncover its story. In the years to come, as the James Webb Space Telescope continues its mission, and new instruments, like the Nancy Grace Roman Telescope or next-gen ground observatories, come online, we will sharpen our understanding. We may map the atmospheric layers of exoplanets. We may detect biosignatures, chemical hints of life. We may even spot seasonal changes, rainfall patterns, or something unexpected, something that doesn't fit, something that demands a second look. And when that happens, the question shifts from could life exist, to what kind of life is out there. The universe is not silent, it's speaking in waves of light, in gravitational echoes, in the subtle signs left by worlds we have yet to touch. And now, we are finally learning to listen. Our hypotheses about distant worlds are offering concrete data that can either confirm or challenge our theories. And just when we believed we had discovered all the mysteries of this cosmic exploration, something unexpected happened. Researchers using the James Webb Space Telescope detected an astonishing signal from Proxima B, a signal so intricate and unusual that it sparked excitement and debate among scientists worldwide. On social media, this signal was dubbed a potential technosignature, a so-called electromagnetic radiation, strange and complex, that raised the possibility of cutting-edge technology and civilizations. For a brief time, the collective heartbeat of humanity seemed to stop and marvel. Could this be the breakthrough discovery proving that we are not alone in the universe? Yet, as soon as the signal was received, it vanished, leaving behind a profound silence and a multitude of unanswered concerns. Whether this was merely a cosmic fluke, an oddity of nature, or something more deliberate, perhaps an encrypted message or a signal from extraterrestrial intelligence, this single signal has produced a cloud of mystery surrounding the explosion of Proxima B. Fierce debates and theories about its origin began. Was it a brief blip, or could it be part of a larger narrative, one more complicated than we can even imagine? But hold on. The story doesn't end there. The quest for answers continues, and it is no longer ordinary. Researchers from Harvard and other institutions are pushing the boundaries of our understanding. They are transforming the James Webb Space Telescope into a kind of cosmic night vision device, searching for artificial light sources in both the dark and illuminated regions of distant worlds. The possibilities in these worlds are staggering. Imagine detecting the glow of cities on planets far away, their lights piercing through the darkness like beacons of advanced civilizations. This is not just about the search for meaning in life, it's about locating evidence of intelligent beings shaping their environments in ways we might not have taken into account. As we dig deeper into space's vast expanses, the search for alien life on other planets takes on new dimensions. This search, fueled by rapid advancements in technology and a deep curiosity about our place in the cosmos, drives us to look beyond Proxima B and into the universe's farthest reaches. Tools like the James Webb Space Telescope, alongside ground-based observations, provide an unparalleled understanding of exoplanets. This opens up new ways to learn about life and understand the potential habitability of these distant worlds. Among the most intriguing areas of exploration is the search for chemical biosignatures, markers in the atmosphere of a planet that could indicate biological activity. These could consist of gases such as methane or carbon monoxide, which, under the right conditions, may indicate the presence of life. With the capabilities of the James Webb Space Telescope, scientists can now examine these chemical signatures with incredible precision. By studying the illumination that passes through an exoplanet's atmosphere, astronomers can identify important water vapor molecules, oxygen, and ozone, all of which could point to conditions suitable for life. In addition, the study of these planets' environmental conditions is crucial. Models based on Webb's data help predict whether a planet's temperature could allow for liquid water, which is essential for life as we know it. Planets in the habitable zone of their stars are of particular interest, since they may have the right conditions for stable liquid water to exist. The search also extends to moons orbiting these exoplanets, some of which may harbor subsurface oceans beneath their icy crusts, much like Europa and Enceladus in our own solar system. Beyond biosignatures, the concept of technosignatures is gaining momentum. These are potential signs of extraterrestrial technology, whether it's massive energy harvesting structures like Dyson spheres or strange radio transmissions. As we refine our observational techniques and build greater global collaborations, the search for technosignatures could provide the long-sought evidence of advanced alien civilizations. In this grand endeavor, collaboration is essential. Collaborations between space agencies, research institutions, and private companies are enhancing our collective ability to explore space. As we pursue missions to other celestial bodies like Mars, nations are pooling resources and expertise to reach new heights in space exploration. Public engagement is also essential to keeping the excitement alive, inspiring the next generation of scientists and engineers to continue the search for life in the universe. In conclusion, the exploration of exoplanets and the search for extraterrestrial life is a dynamic and rapidly evolving field. With every advancement, we edge closer to answering humanity's most profound questions regarding our role in the universe. As we continue to explore the stars, the possibility of discovering new forms of life and gaining a deeper comprehension of existence remains exhilarating and boundless. This quest for knowledge is more than just an intellectual pursuit, it is a testimony to our curiosity and desire to connect with the cosmos in a meaningful way. With each new discovery, we challenge the very notions of life, intelligence, and the nature of existence within such an expansive universe. Whether it's through the detection of chemical traces from faraway atmospheres or the potential observation of alien technologies, the hunt for extraterrestrial life continues to captivate our imaginations. The implications of finding life beyond Earth would not only redefine our understanding of biology, they would also forever change our perspective on our place in the grand tapestry of existence. As humanity pushes the boundaries of discovery, we find ourselves standing at the precipice of a new era, one where science fiction inches closer to scientific reality. The detection of life, intelligent or otherwise, would mark a turning point in our civilization's story. It would raise urgent questions. How do we communicate? Should we even attempt to? What if they're more advanced? What if they're not? These are no longer abstract musings, they are becoming necessary considerations. Philosophers, ethicists, and scientists alike are engaging in deep discussions about how to prepare for such contact. Protocols are being drafted, and ethical frameworks are being debated, not for if, but when we make that connection. Meanwhile, the search itself continues to evolve. With new missions on the horizon, such as the European Space Agency's Ariel mission, or NASA's upcoming Louvois Observatory, our tools are becoming more refined, more capable, and more focused. Each new instrument brings us closer to decoding the cosmic whispers from distant planets. But the journey isn't just technical, it's deeply human. There's something profoundly unifying in this quest. In a time when our world faces divisions and crises, the search for life beyond Earth reminds us that we are all passengers on the same fragile planet, spinning through the vast darkness together. It reignites wonder. It inspires cooperation. It urges us to protect what we have here, even as we look outward. And maybe, just maybe, it prepares us for a future where we're no longer alone. Whether through a faint radio pulse, a flickering light on a distant planet, or the chemical fingerprint of alien biology, the first definitive sign of life beyond Earth may come quietly. But its echo will be thunderous, changing not only our understanding of the universe, but of ourselves. This is more than science. This is legacy. This is the next great chapter in the human story. And it's only just beginning.